In long context question answering, one of the most persistent challenges is determining how much context to include for a given query. Include too little, and you risk missing critical evidence, especially in multi-hop reasoning tasks where answers depend on connecting multiple pieces of information. Include too much, and you flood the model with noise, increasing inference cost and degrading performance through attention dilution, and the infamous lost in the middle phenomenon, where key information buried in the middle of long prompts gets ignored. Traditional approaches, like fixed top-K retrieval or single-stage reranking, fail to resolve this dilemma. They either under-retrieve, leaving important clues behind, or over-retrieve, introducing irrelevant passages that confuse the model. Even with powerful dense retrievers and LLM-based rerankers, the final context is still typically a rigid prefix, the top K passages, regardless of query complexity. This is where Context Picker comes in, a reasoning-aware framework that fundamentally shifts the paradigm from similarity-based ranking to minimal sufficient subset selection. Instead of treating retrieval as a sorting problem, Context Picker models it as a decision-making process. For each query, the system learns to construct a compact, evidence-rich set that is just enough to answer the question. At the heart of Context Picker is a two-stage reinforcement learning schedule, inspired by human problem-solving. First, we prioritize coverage, then we refine for precision. In stage I, recall-oriented, the policy learns to maximize information coverage, tolerating some redundancy to ensure no reasoning chain is broken. This is crucial in multi-hop QA, where missing even one piece of evidence can derail the entire answer. We allow a relaxed redundancy margin, so the model explores broadly, capturing all potentially relevant passages. Then in stage II, precision-oriented, the objective shifts. The redundancy penalty is tightened, and the policy learns to aggressively prune weakly relevant or redundant passages. The goal is no longer just to include everything that might help, but to distill the context into a clean, noise-free subset that preserves answerability, while minimizing token usage. But here's the challenge. Training such a policy with sparse task-level rewards, like final answer correctness, is unstable and inefficient. To overcome this, Context Picker introduces an offline evidence distillation pipeline. Using a generator, judge loop, and a leave one out (LU) pruning procedure, it mines minimal sufficient evidence sets from raw documents. For each query answer pair, it starts with a retrieved set, then greedily removes each passage one by one, checking whether the model can still produce the correct answer. If removing a passage doesn't break the answer, it's deemed redundant and discarded. The final set is the smallest possible subset that still supports the correct answer, our golden training signal. This distilled data provides dense, task-aligned supervision. Instead of waiting for a final answer to judge success, the policy learns per passage contributions, which pieces are essential, which are superfluous, and how many are truly necessary. To train the policy, we use Group Relative Policy Optimization, GRPO, a robust reinforcement learning algorithm that compares multiple candidate selections for each query and updates the policy based on relative performance. The reward function is carefully designed. It rewards high coverage of the golden set, penalizes redundancy in a stage-dependent way, and enforces structural correctness through format penalties. The result is a system that learns not just what to pick, but why, and how many to pick. At inference time, Context Picker runs in a single pass. Retrieve candidate passages, apply the learned policy to select a minimal subset, and pass that to the generator. The output includes both a natural language rationale and a list of selected IDs, ensuring end-to-end consistency and interpretability. We evaluated Context Picker on 5 major long context and multi-hop QA benchmarks: Locomo, multi-field QA, Hotpot QA, 2 WikiMQA, and MooSequa. Across all datasets, Context Picker significantly outperforms both vanilla LLMs and strong RAG baselines. On 4 of the 5 benchmarks, it achieves higher answer accuracy, sometimes by over 10 percentage points, while using comparable or even fewer tokens. Notably, the two-stage design is critical. Stage I provides a robust high-recall foundation. Without it, the model tends to overprune, missing essential evidence. Ablation studies confirm this. Removing stage I drops performance by 14 points. Similarly, removing redundancy-aware reward shaping leads to a 4.6-point drop, showing that explicit modeling of length and redundancy is essential. And removing the rationale generation branch causes a 6.5-point drop, suggesting that requiring the model to explain its reasoning acts as a stabilizing regularizer. These results demonstrate that Context Picker isn't just a better retrieval strategy, it's a smarter way of thinking about context. It moves beyond static heuristics and fixed budgets, learning to adapt both what and how much to include based on the reasoning demands of the question. In summary, Context Picker introduces a new paradigm in retrieval-augmented generation, minimal sufficient subset selection. By combining offline evidence distillation with a course-defined reinforcement learning schedule, it achieves superior accuracy with improved efficiency, bridging the gap between recall and precision in long-context QA. It's not just about retrieving more or less. It's about retrieving just right.